Wrapping up section 3.1, we have implicit domain restrictions. So this is when we're looking at things like something with a variable in the denominator. So we're restricted to some facts like some rules, right? Some math rules that we've known for years. One is there's denominator cannot equal 0. And 2 is that a square root is greater than or equal to 0. So let's look at how this applies in an example. So number 14, let's look at example A. Let's do f of x equals x minus 1 over 2x squared minus 32. So we ask, what can x not be? What is the restriction? Well, there's no square root, so I'm not worried about rule number 2, but rule number 1 says a denominator cannot be 0. So to find my domain, or I should say my domain restriction, I'm going to say that this thing cannot be equal to 0. So I just solve for the equation where it is equal to 0 to find out where x cannot be. Okay, so then solving this equation, I get 2x squared equals 32. Dividing both sides by 2, I get x squared equals 16, and then I get x equals plus or minus 4. So x cannot be negative 4 or positive 4. What happens if I plug in a 4 there, I get 2 times 16 minus 32 is 0. So that's a problem. So here's my domain restriction. So x cannot equal positive or negative 4. So what does that mean my domain is? So I can state it like that. Or if I'm asked to state the domain in interval notation, then I would write, so this is the domain restriction, right? Domain is not equal to plus or minus 4. So that means it could go from anywhere to negative infinity all the way up to negative 4, not include 4. And then it can go from negative 4 to positive 4, not include 4, and then from 4 all the way to infinity. So this is the domain with that restriction. Okay, let's try another one. Let's do B. So for B, let's let our function be the 6th root. Oh, you know what I need to specify here. My rule is I should say even root, not square root. Because as long as it's even, squared, 4th root, 6th root, 8th root, 16th root, not odd, because a third cubed root of x can still be positive or negative, but a square root cannot. Okay, so for part B, the example is going to be the 6th root of negative 9 minus 3x. So since it's an even root, 6 is even, so that means my negative 9 minus 3x must be a positive number or 0. It's non-negative. So it's greater than or equal to 0. So this is my restriction. So I need to solve this, and I get add 9 to both sides to isolate the term with the x, and I get negative 3x is greater than or equal to 9. And then I'm going to divide both sides by negative 3 to get x by itself, and I get, you know what? When I divide, I got to flip the sign. When I divide by a negative, and then I get negative 3 here. So this one's not equal to. The previous one, our restriction was that it's not equal to 0, so I solved equal to 0 to find out what it's not. For this one, I set it equal to or greater than 0, which is what it can be. So this is our domain here. Okay. In interval notation, that's going to be all the way from negative infinity all the way to negative 3, including the negative 3 since there's an equal sign. Okay, let's do two more. Let's do f of x equals the cubed root of x minus 1 all over x. So since it's a cubed root, I can always separate a root, a quotient of a root into the root of a quotient into a quotient of a root, so I can split it up like this. And again, this is a cubed root. Now that's an odd root, so that means I don't have any restriction with that radical. The only restriction I have here is that the fact that the denominator cannot be 0. So if a cubed root cannot be 0, that means the only thing that can't be 0 is x. So that's my domain restriction. So my domain is everything but 0. So in interval notation, that's negative infinity to 0, not including 0, and then 0 to infinity. So this is interval notation, which your book uses a lot. This is also a common way to write it, both those ways. State that domain.